Okay, so today we have a Trane gas furnace. So it's natural gas, 80% efficient. It's got a two-stage motor, so it's got two stages of heat. And basically the customer's saying that there's no heat. Obviously the heat's not running. So I already diagnosed this, like I think last week. But finally we were able to get the board because it had to come from New York and there was a whole bunch of issues with it. Anyway, this particular furnace is not your typical, standard furnace. This actually has a module that's got a chip built into it, and it kind of communicates with the whole system. So let's see if you can get a better look at what the module looks like. So in here, there's this module right here, and it's got a chip right here in the bottom. It's a code chip. So this pertains to this particular board in this particular furnace. So you'll see that it's going to match the model and serial number. Usually the model and serial number of the unit will match to whatever it's in this particular chip area. And all it is, it's just you literally just pop this in right here. It's just the prongs you see right there, and it goes right back in here. Now we're going to be replacing this board, and here's why we're going to be replacing the board. So initially this thing was throwing a bunch of different error codes. There was an error code in this screen right here that showed that the system was not communicating properly with the module. But then we reset the power, restarted everything. You can tell that the igniter has been changed once before. You can see the the connectors right there that they made a splice. A couple things have been done to this unit apparently, but this thing, when I reset the system and started recycling, it was basically throwing an error 3 blink error code on these lower LEDs located right here, which I know they're kind of hard to see, but there's two LEDs. There's a red one and a green one right here. The green represents that there's power present, and then the red one will usually flash and blink a certain amount of times before it tells you what particular error code that may be. Now I did this, and I did this to keep power on because right now I have the switch off. But yeah, this basically will keep the power on. So that 3 blink error code, it says that the pressure switch, which is this guy right here, has failed to close, so it remained open. Now typically during a call for heat, the first thing that kicks on is this guy right here. So this motor starts to spin. As it spins, we are now exhausting the gases out. That spinning cycle is tied in. You look where the motor is located right here on the heat exchanger housing right here. Okay, this is the air box. So essentially we are pulling air through here, and that is going to close the switch. So think about it, air is being pulled from this hose inwards, goes into the motor, comes out the flue. So when this thing gets pulled in, this switch closes. So it creates a contact between these 2 points, and it closes that contact, saying that, hey, my motor's running, now we can continue on with our heating cycle. If the motor was not running, or there was an issue with the motor, this guy will obviously not close, thus giving us the error code that we see down here. Now this happened multiple times. So the next thing that we did was basically, see if I can put this right here. Let's see. Yeah. Okay. So there's primarily 2 things that you can do to check whether a motor is good or bad, right? So number 1, we need to establish that we have power, okay? Because if we don't have power going to your motor, then the motor will not spin, right? So obviously we want to make sure we have your line voltage power coming into the unit, which you can check down here. So you'll find the power coming in from the switch. I mean, there's a couple ways you can go about it. You can either trace your wiring from this point right here, the black and the white. This is a 120 volt application, so you have a hot and a neutral. So you'll trace that back into the board. Make sure you have power in the actual board itself. At that point, you've established that you have 120 volts, and your power is good. Like you actually have power in the unit. Now, because of this particular board and this particular setup, you also want to make sure your polarity is correct. So you want to make sure that obviously you go to ground on each leg and there's no voltage on the neutral side and nothing like that, because that can cause this particular board in this scenario to have issues, right? So anyway, we established that we don't have a polarity issue when I was originally here. So we checked everything to ground, make sure everything was good. So we're back here to square one. So our motor is going to fail mechanically or it's going to fail electronically, right? And what I mean by that is, so mechanically, the motor is going to fail because you won't see it spin this free. Like, you see how free it spins? Like that's pretty free, right? So if a motor was stuck, it won't spin like that. It would be kind of hard to turn this wheel, right? So right now, this tells me two things. The motor is not stuck. The bearings seem to be okay. The blades aren't caught on anything. There's no bird that flew into the exhaust pipe or anything like that. So this tells me, for better lack of sense, that this is fine. Like, we have good rotation here in the motor. Now, the next thing that I'm gonna check, obviously, I did an ohms test on the motor just to check resistance along the windings and everything, and everything's checking out fine with this. However, when we check power on the bottom side here, so during a call for heat, the first thing you're gonna get is 120 volts on this particular thing, or a lower voltage depending on the stage of heat, right, that we're calling for. So we check neutral to each leg, and we have nothing. We have maybe 0.7 volts. So we start with 0, and we go to 0.7 volts during the call for heat. That tells me right there that we're having an issue further down in this board. So down here, in this board right here, we're not getting the power that we need up to the actual motor. So the issue here is not necessarily the fan motor, even though that's what the error code is calling for. Like, hey, we have a pressure switch error code and my fan's not spinning. But the issue is more over here in this board. So when the relays close, to get to that, to get the voltage transferred up here to this motor, we either have a relay that is not closing or stuck, or something's going on where we're not transferring the correct voltage to the right application that we need to run. So we're going to be replacing the board today, and basically you're just going to watch me. It shouldn't be that difficult. Now the only thing is, this particular one, like I said, you do require this chip that comes with that you have to remove from the old unit to put it into the new board, so that it matches the algorithm from the previous unit to the new one. So this is the things to keep in mind. But we're going to be replacing this board. So this is a new board right here, as you can see, pretty much identical to the old one. Obviously, you have your bottom terminals right here for your low voltage terminals, different relays. You have your chip for the algorithm. Then you have obviously the different prongs. You have your 24-volt fuse right here, and we're basically just going to be at this point plug and play. But then obviously we're going to go over everything else just to kind of make sure that everything's matching up and lining up and everything. So at this point, you're just going to watch me take this apart. All right, so. We have W1 and W2 jumped. So we're going to do the same thing. W1, W2 is jumped. Okay, so what they're doing right here, they have W2 and W1 jumped, which means when W1 calls for heat, which most likely that's what is wired into the thermostat, it'll automatically call for W2, or vice versa. essentially, what this does really is that it kind of takes away from that ability of the furnace to kind of run at a lower stage, because you're just calling for the same stage twice. So instead of like it being, you know, a unit where it'll cycle like 40% or 100% capacity depending on demand, right? It just goes 100% all the time. So again, what's the point of having a high efficiency unit if you're going to do that, right? But unfortunately, they don't have the extra wire that they need, and they don't have the proper thermostat for that. So again, we're just going to jump it out. It's going to come on 100% capacity, but it does take away a little bit from that efficiency of the unit. But at least we'll get them heat, right? So again, everything kind of communicates in this system. So it's all meant to be communicating and work together with the board, so the board can see what everything's doing, right? That's essentially what's happening. As compared to another unit where like you have a failed motor or a failed something, like you won't necessarily know until you do a bit more digging. This particular unit will kind of tell you like, hey, the motor's not working or something like that. So. So it's got these little these little white clips that go into the back of the board. So you got to take off all the white clips, so you can just kind of like prime off. But usually there's 4 of them. This one has like six or 8. It's like almost little needles, and those needles tend to separate over time. And this guy right here, again, they tend to kind of expand a little bit over time, so then they don't make a good contact. And you may think that you have a bad board, but in reality, you know, you have a bad harness. So just keep an eye on that over time. Obviously these look fine, like they don't look that they're separated or anything like that. And a lot of times you'll notice that because if you kind of like jiggle it, or just kind of like, you know, put your probe, like put your meter probe in there, and just kind of like do one of these and get them to kind of all crimp up. You turn the power back on, and the unit will run. So like you'll notice that you're losing something somewhere, and it might be because of these harnesses. So just double check that all the time. But we're gonna mount the new board right now, which is this guy right here. This is the digital readout display. And this is kind of what communicates with everything. So definitely make sure there's no dirt or anything, because see how small those are? You definitely want to make sure that's all good. Now, this is important. We need this because this will have the model and everything else that this unit needs to operate on. So the unit knows that, hey, this is what I am. This is my kind of like my code. So this is what I need to run. If you were to put something else in here or don't put nothing at all, the unit will throw all sorts of weird error codes and obviously not know what to do. Oh, also whenever you replace a board, take off the fuses and save them. You know, you never know. You find yourself with a low voltage short, you pop in a bunch of fuses, yeah, they come in handy. Or just get a few little fuse popper. I mean, you know, but it's there. Why not just take it? Alright, so this is
this cotton wire was super brittle. It just broke off. So we're gonna make sure that we get a nice piece of solid wire. Let's see here. Actually, I might as well just redo all of these. My camera skills, they suck. Let's see, where's my blue? Where's my blue? Oh, there it is. Oh, what the hell?
Now you have that by itself, which is exactly what we want to see. Now we're just gonna let it go through its heating cycle. So now we see the hot surface igniter coming on. You can see the orange light right there. Momentarily, the gas valve is going to open, allow the gas to flow on all the burners, which it did. And now we're gonna be waiting for a flame sensor signal. So the flame sensor is going to sense the flame, and it's going to allow the blower motor to run. So what we're going to do, we're actually going to do this real quick. Let's see. Second stage kicked on. So second stage kicked on. Where's something I can use to no, yeah, fans on. That's good. I just want to see a temperature difference, just to see what we're getting out of there, and then I'll compare it to my return right here, which clearly we're moving. Yeah, it's good. So yeah, but that was a kind of an easy thing to kind of diagnose and see. I mean, it's not your typical board that you're running into, just because it does have all these like communication modules and little interfaces that you have to kind of make sure that you plug back in the right spots. And then there's this guy right here, which is basically, like I said, just the kind of the brains of the unit and tells it what it is and stuff. So I'm gonna keep an eye on it, make sure that you know, my split is good as far as temperature rise, because right now it is running on 100% capacity, because that W2 terminal was jumped out. So I'm gonna keep an eye on it, make sure that it's fine, and should be good to go. My next call, I think, is like a water main in a commercial building in Newark. I'm not recording that one. I want my phone getting wet. But yeah, catch you guys in the next one, and I'll try to upload some more of these, you know, as the season goes on. This are not nice because the customers are not even home. She left me the key and said, okay, you know, get my heat back on. I said okay. But yeah, later.